probably a little bit easier in this case than even bothering with the graph, just because I don't know if those are going to be whole numbers yet. So we're basically, they're telling us to go from 0 to 3. They tell me n is 3. They get down here to say, I think n is 6. But we'll set this up. And so we'll evaluate this, and then remember we're thinking about left hand versus right hand. We'll talk about what that means about our table. Hopefully you remember that. But figure out those values. And then we're probably going to end up having to make a second table for when n is 6. So we'll deal with that when we get down here. So we're basically substituting these values in here. So our left-hand Riemann sum basically is going to take the left side and work its way over. So we're going to be able to leave out this last one over here because we're basically going at 0, 1, 2, and like basically making the rectangle go from that spot. So hopefully you realize already that this left-hand Riemann sum is going to be an underestimation because it's going to leave out that larger number. So we're not really seeing that bigger number part of the graph. So left hand looks at those three together. And you just add up the values. Whereas the right hand does the opposite. It looks at the last three then. And so that actually ends up being 0. So this is like kind of an, I guess like an upper estimation. But then they ask us to go n is 6. That means they want more category or more like dividing lines between these. So we're going to do that. So we kind of need half points in this case. But there's also another little piece we have to remember here too. Right, we have to go a half. And they want the right-hand Riemann sum. So over here. So we still have those other values to use up here. I have to redo those. I'm just going to round to the tens place for sake of not having to do. So we're going to put those all together. But but since n is 6, do you guys remember the other piece of this that we have to include? Yeah, we have to multiply it by the fact that now our little, our rectangles are smaller. So our rectangles got shorter, so when we're thinking about, so when normally we do the base times height, remember we're still finding the area. Now they just got skinnier, so the base is actually only 0.5. So we're going to take half of this. Now, one of the things I want to mention is, so there was an upper limit, a lower limit, or a lower value, and then now we're kind of somewhere in between there. Do you guys remember as this n gets bigger, what happens, like what do we know about this number? If that n keeps getting smaller and smaller, what do we know about that number? It's more accurate. The more rectangles you make, the more accurate this becomes, because all of a sudden the rectangles start looking a lot more like the curve. They become skinnier and skinnier. As much as it's annoying, the bigger the n is, probably the closer we are to the actual value. And again, this is the long way to figure out like the value of, so if we wanted to do this like the short way, we could figure out from 0 to 3, but that's not what they're asking us to do. So we like do that antiderivative. So they're asking us to do left hand, right hand. So kind of going through that process. But as n gets bigger, we get closer and closer to the actual answer. So if you want to flip the page over, these were two that we kind of talked about this a little bit, but the format was different than maybe what you guys see right now. And so I want to make sure what's clear here. They don't give us any values for the integral. They don't tell us from like 0 to 3 or -2 to 5. They just want the antiderivative. This is where we're going to throw in that c, because we don't necessarily know what what the original function was. So we are going to do the antiderivative, but then we're also going to add c on the end as that constant. Because remember, when we take the derivative, a constant like kind of just drops off. So we'll mention that here as we go through this. So we're basically just doing the antiderivative, figuring out that reverse of what we did before, and then just leaving it. So we're not actually substituting values in. So if you recall, we take it and the variable gets a higher power. So this one is really like x to the 0. So this becomes 16x to the first, and then you divide by that power. The 6x to the third, divide by the power, but then I'm going to put a plus c. Now we don't need to do that when we are actually evaluating these, but when they're asking us just for the antiderivative of the integral, we want to include that constant, because technically we're going back to find that derivative, or going like kind of talking about derivative versus antiderivative, sorry. So this would be considered our full antiderivative. So on the test, if they ask for the antiderivative and they don't give you those values, this is what we're looking for. And I just wanted to make sure that was clear, and I don't know if I explained, I don't think I put it in this notation before, so I just want to make sure the difference between that and when you're actually finding the value, they'll give you those numbers. So kind of just noticing the difference. On the review you guys will get today, it'll have both on there so you can see the difference. So again, raise the power up, divide by that number. So this becomes 12x to the fourth. And if you don't need to show this step, like if you're just like, well, that's 3, why does she keep writing 12 over 4? I'm just trying to remind you guys how we did it, just in case it's not set in stone in your head yet. And then again, the plus c is because when I take the derivative of that, it just cancels out. Now this one is going to have a fraction, that's okay, especially since we don't have to evaluate it. So that would be our antiderivative then. So just a little notation thing that I don't think I was super clear on, and then like I said, looking at Mr. Hatfield's test from years past and just trying to make sure I'm aligning things the way he wants them for when, if you decide to take another, you know, like a calc class here, I want to make sure you guys are comfortable with like the notation he's using, and hopefully other people are using too. I know there's different things depending on the textbook and stuff, so I'm just trying to make sure we're kind of all on the same page. So I will get you guys the review. You guys can work on the review and your note card today. So again, the note card will be for our test, which hopefully will be tomorrow. I'm thinking we'll be okay on it. Like I said, I have a couple of mini lessons, and then I was thinking of next week for a review for the exams. So I think that's probably good timing. I will probably print off an exam schedule for you guys tomorrow. I just don't have it today yet because I'm trying to make sure the times are all the same that I thought they were. Where did I put our worksheets? Now, also know that I didn't put absolutely every type of problem on this review, so some of the stuff we talked about yesterday, like those velocity time graphs, I didn't put one of those on here. So that was the one about the train, you know, the train traveling, how far, you know, when is it slowing down. So just know that like questions like that from our book yesterday could also be on there. So this is not like an all-encompassing review. So kind of combine this with what we talked about yesterday. So make sure maybe when you're making your note card, you have the sheet out from yesterday and today's, or even from other sections